Welcome to Lesson 11. In this lesson we will talk about inheritance and polymorphism in Solidity. In classical object-oriented programming, inheritance refers to a case where a subclass uses the structure and behavior of a superclass. Polymorphism refers to changing the behavior of a superclass in the subclass. The same principles apply to inheritance and polymorphism when developing Ethereum smart contracts, and the general inheritance system is very similar to Python's or Java's, especially concerning multiple inheritance. When a contract inherits from multiple contracts, only a single contract is created on the blockchain, and the code from all the base contracts is copied into the created contract. Now let's have a look at this full example here, where we explore how inheritance and polymorphism works in Solidity. If you are a bit lost, don't worry, once we have a look at an example, it should be a lot clearer. So let's go to Remix IDE, make a new file, copy the code, and now let's start inspecting what it does. So at the top we have this first owned smart contract, which has only one constructor, owned, and in that it sets the owner who set up this contract and stores the owner in the owner state variable. Then we have a mortal smart contract, which derives from owned by using is syntax. Derived contracts can access all non-private members, including internal functions and state variables. These cannot be accessed externally via this. So note how in this smart contract we have owner variable accessible. This is only because mortal is derived from owned. If it was not, if it didn't inherit from the owned smart contract, it would not have this owner state variable accessible. Now let's have a look at this car smart contract, and we will make use of it soon. So this smart contract only takes one parameter in its constructor, and that's the make of a car, and then we set it like so, and it has only one getter where it gets the make of a car, and another is simply a pure function which returns a string vroom. We will override this string in a smart contract later on. Then we have the thing contract, which takes two parameters, color and cost. And it has getters for both of these, getColor and getCost. And finally, we have a Toyota car smart contract, which is both a mortal and a thing, and also a car. So how can this be? Well, first of all, in its constructor, when we define the new Toyota car smart contract instance, we also initiate thing and car smart contracts. So we pass the color and cost to the thing constructor, and we pass the hard-coded Toyota string to the car smart contract. Now what will happen is that Toyota car will inherit all the state variables and functions of thing, car, and the mortal, and will be able to make use of them in its own Toyota car smart contract. So for example, we have this setter function where we set color, and this would not be possible if we didn't inherit from the thing smart contract, because as you can see, we do not declare the car in here like this. The color, we do not declare the color in here like this, for example, but we can still set the color. This is only because we inherit from the thing smart contract. And also here, as you can see, we override car make noise method via polymorphism, and instead of returning vroom, we return Hurray. Now let's compile this smart contract by using JavaScript virtual machine. Choose Toyota car to be deployed and pass some parameters to it. So the color will be red and the cost will be 100. And we have our smart contract deployed. Now as you can see, the make noise returns Hurray. Get make is Toyota, get cost is 100, and get color is red. Now we can set the color to blue, for example, and the color, if we retrieve it, will be blue. Now, if we go to another account and try to kill the contract, and then go back to our previous account and try to do something with it, like set the color to yellow, it will still work. This is because only the person who created this contract can kill it. This is because we inherit the mortal smart contract. But if we try to kill it ourselves, and now try to do something with it, like set the color back to blue, it will not work. This is because, as you can see, we get an error which says that it cannot read property op of undefined. Now you may ask, why to use inheritance and polymorphism at all? Why don't just put everything into one contract? The main benefit of inheritance and polymorphism is code reuse. So you can make your own functions which you will reuse in your programming career. Also, there are projects like OpenZeppelin, which has lots of reusable and secure smart contracts for you to reuse, so you don't have to waste time implementing them by yourself. So this is it for this lesson. In the next lesson, we will have a look at exceptions. I'll see you there.